Did I get it? After all, I am interested in one spanning tree of my interest. Is there any way to straight away go to? Is there any way to straight away go to what? A spanning tree of my interest. Not necessarily minimum spanning tree. I may be interested in moderate spanning tree. I may be interested in maximum spanning tree. I may be interested in mode spanning tree. I may be interested in mean spanning tree, right? I mean, look at amongst you all, I may be interested in the tallest tree in this auditorium. I may be interested in fattest tree in that auditorium. I may be interested in the guy of height average, a guy of height mode. Yes or no? Of course, my lecture today is supposed to be on shortest guy. Is this understood? Okay? So this is, I mean, you do the cyclic exchange operation. You do the cyclic exchange operation. Now the question is the following. Can we start from any spanning tree and get a desired spanning tree by a number of cyclic exchange? Can we get all spanning trees of G in this fashion? Yes or no? Yes. I don't want to give concrete answers. I want to leave these questions as assignments to you all. Right? Till yesterday, you have programmed to Wednesday or Thursday? Right? How long will we have to do? New exchange yet? You mean, how do I assure that no more spanning tree will be generated? Look at here. What is your condition? What's your condition? Your condition says that repeat this till no more spanning tree can be generated. How do I assure that no more spanning tree can be generated? Generates 10 more. If those 10 happen to be other existing, that doesn't mean that 11 is not something new, right? Are you following me or not? That may be lack of your knowledge. I mean, how do I ensure that this condition is met? How do I ensure that this condition is met? That's the next question here. Is there a preferred spanning tree to begin with? Is there a particular spanning tree which I can begin and comfortably generate all spanning trees as quickly as possible? Then which one is preferred? Clear or not? Is it okay? Let me answer these questions. Right? Is there a preferred spanning tree? Then the concept of metric distance to the came into picture. What is the distance between two spanning trees? I give you a spanning tree T1, I give you a spanning tree T2. Can I measure a kind of similarity and dissimilarity between two spanning trees? So because this is one spanning tree, this is another spanning tree, this spanning tree can always be generated from this spanning tree by the use of which operation? Come on, cyclic exchange operation. How many cyclic exchange operations you are supposed to perform to get this spanning tree generated from this spanning tree is called distance between two spanning trees. And notice here, this distance is symmetric. What do you mean symmetric? If you do two operations to generate this from here to here, again with the same two operations, you can get this back. Then I say this distance is asymmetric. Did I get it? And this distance is always non-negative. You have to do operation, right? You cannot take away the operation. Then then the distance is always greater than or equal to 0. If you consider two spanning trees which are identical, then the number of exchange operation is 0. Then it is minimum 0, and anything above 0, I mean it is non-negative. And I have a spanning tree here. I have a spanning tree here. From here, I do some number of exchange operations. I got this. Again, I do some exchange operations on this. I get this third one. And if I do exchange operations on this to generate this directly, then this direct way is supposed to be less than or equal to this plus this, and we call it as triangular inequality. Did you get it? The function which satisfies these three is called symmetric, non-negativity, symmetricity, and triangular inequality. This what is called symmetric. Okay, the distance measure has been introduced as symmetric, and now what do I do? If there are number of spanning trees, don't expect me to leave you at 11:30 because I started at 10:30, right? Don't look at your clock. Okay? So if there are number of spanning trees, then measure the distance, and choose a spanning tree which has got relatively less distance with all the remaining spanning trees. And such a spanning tree is called center of the family of spanning trees. Okay, appreciate now. Again, what do I do is, if every one of you consider to be a spanning tree, then I measure the distance. T1 to T2, T2 to 3T, T3 to T4, etc. Mutual distances. Then you choose a spanning tree which is closer to the remaining. Then if you start with this spanning tree, you can quickly generate all remaining instead of starting with something which is here in the border. And if you want to cover entire Karnataka, better start with way, not with the border. Better start with the center of the Karnataka state. If you want to span across, if you want to go across, the best part to choose is what? The center, because the algorithm recursive works. So algorithm recursive works. It goes on hookupping in all dimensions. Then better to choose the center. The distance, the maximum distance it has got with any other spanning tree is what is called radius. The center of spanning tree. Radius is the spanning tree. I mean, every spanning tree can be associated with its own radius. Choose the spanning tree which is with minimum radius. That's what the answer to the question. But what are the algorithms? How to design such algorithms? Those are not the questions we can answer in this session, right? Let me move on to the next one. Now my interest is to find a spanning tree in a weighted graph. Weights have been given to every edge in the graph. Now I am looking for a spanning tree. Okay. When I come out with a spanning tree, in that spanning tree every edge has got a weight. Sum them up and see that generally the weights are positive. Sum them up, right? Even if they are negative, you need not bother. But it's better to work with a positive weight. In case if any edge is of negative weight, you sort them and shift them so that you will have a normalization. That solves the problem. In case if any edge happens to be with negative weight, you go for data normalization. That helps you to overcome the problems of negativity, right? Negative edges. So anyway, you take up a spanning tree T1. You take up a spanning tree T2, take up a spanning tree T3. Add the weights of all edges in T1, add the weights of all edges in T2, add the weights of all edges in T3, and this total weight is called the weight of the spanning tree. If your graph has got 100 spanning tree, every spanning tree is known with a total weight, right? Across all 100 spanning tree, one of them or many of them have got the minimum weight. A spanning tree with such a minimum total weight is what is called minimum spanning tree. Hope you appreciate it. Okay? Okay? What is a weighted graph? A graph in which each edge is with a weight. And minimum spanning tree is generally abbreviated as MST. A spanning tree is a minimum weight. Okay? The minimum weight. So look at now. The first one is a graph where each edge is in a weight. How many edges we have in the first graph? How many weight edges? We have 5 edges and respective weights are 1, 2, 3, 2, 4. Now first one is one spanning tree, the second one is another spanning tree, the third one is one more spanning tree, right? Agree? Okay? Then add the weight. What is the weight of the first spanning tree? What is the weight of the second spanning tree? What is the weight of the third spanning tree? 7. This is the minimum spanning tree. Either the first one or the second. The minimum spanning tree is not necessarily one in number. The minimum spanning tree is a tree whose total weight is minimum compared to other. I mean, rest of the spanning trees either have got the same total weight or have got the total weight more than this. Agree or not? Okay? So if this is considered to be the minimum spanning tree, then the remaining spanning trees have got the total weight either equal to the weight of this or greater than the weight of this. Okay? So a tree is chosen to be a minimum spanning tree if its total weight is smaller or equal to the weights of all the tree. Understood or not? Should I write down the mathematics on the board? Not necessary. I mean T, I want a T such that weight of T is smaller than or equal to weight of T dash, where T dash is any other remaining spanning tree. Is it okay? Then look at when do we say it is minimum? What are the properties to be minimum?